Today we're going to finish up our discussion on properties of logarithms, and we're going to go ahead and begin with one of the easier ones, the product property. Now the product property of logarithms says if you have taken the log of a number, some base b, and you're multiplying together, we can split this up and write this as the log base b of x plus the log base b of y. Now, kind of give us some examples, like if I have like the log base 3 of, let's say, 10y, I could write this as the log base 3 of 10 plus the log base 3 of y. And we oftentimes ask, oh, why would we want to do that? Well, what if we have something like the log base 3 of 9y, or something like this? I could write this as the log base 3 of 9 plus the log base 3 of y. And hopefully recall yesterday, or from the day before, I could write this as the log base 3 of 3 squared plus the log base 3 of y. We're going to be doing this today. And our rule from yesterday said if the bases are the same, these will cancel. And what I'm left with is 2 plus the log base 3 of y. And I can rewrite that. Our quotient property is the same thing, except for it says if you're taking the log base b of x over y, let me box that in here, this is going to become the log base b of x minus the log base b of y. And we use these expansion properties quite a bit in calculus. Now, in the example, let's say we have the log base 10. Now, let's just do the common log here of 11 over, let's go sine of x. I don't know, I just came up with that one. We could write this as the log of 11 minus the log of sine of x. And that would be our answer. So try this one, the log base 4 of, let's see here, let's do 16 over 3. This becomes the log base 4 of 16 minus the log base 4 of 3. And like what we just talked about, up here, I can write 4 and 16 in the same base. That's 4 squared minus the log base 4 of 3. Those cancel. And what we're left with is 2 minus the log base 4 of 3. We can't write 4 in terms of 3, or 3 in terms of 4, so we're done with our answer right here. Go back and recheck those if you need to. Do them again. Our next property is the power property. And this is the one that says if you take a log, like let's say log base 5, let's do the log base b of x to the n. This is the product that says that you can bring down your power. We get n times the log base b of x. Of course, some examples, very simple. Let's try the log base 5 of x cubed. We could write this as 3 log base 5 of x. Or if we have the log of, let's say, 3x minus 1 to the 1/2, I could write that as 1/2 the log of 3x minus 1. Now be very careful. We can't distribute the log, so please don't go this log of 3x minus the log of 1. We can't do that. So be very careful. So let's take a look. Here we're wanting to expand the following using our properties. Well, here I'm multiplying. So what I'm going to do, because I'm multiplying, I'm going to use my product property and write this as the log base 6 of 5 plus the log base 6 of x cubed. And if you notice here, we have a power. So now I can use my power property. Get the log base 6 of 5 plus, only bring the 3 in front of this log base 6 of x. And that's how we expand it. Very easy to do. Most students tend to really like this. Now, over here, we have a product, a power, and we have some division. So what I tell students to do first is division first, which means I'm going to write this as the log base 3 2y cubed minus the log base 3 of 3. We'll talk about what that becomes in just a few moments because they are asking us to reduce here. Next, we get the log base 3 of 2 plus the log base 3 of y cubed minus the log base 3 of 3. I use my product property. And now I have my power property. Can bring that down to the front. We get the log base 3 of 2 plus 3 log base 3 of y minus the log base 3 of 3. And at this point, let's talk about this. The log base 3 of 3. We know those are going to cancel out because they have the same bases. But what is the power on the 3? It's a 1. So this is just the log base 3 of 3 is 1. So we get the log base 3 of 2 plus 3 log base 3 of y minus 1. And there's kind of a rule here for that one. And we talked a little bit about this yesterday, that the log base b of b to the n is just n. And that's like a little rule for us if we want to write that down again. What I would like you guys to do is try numbers 3 and number 4. See if you guys can try those real quickly, okay? And then let's go ahead and take a look at on the back side, okay? Alright. Let's practice a couple more expanding. I like this one because we have to rewrite it as in the exponent rule. This is the log base 2 of x minus 2 to the 1/3. And I'm going to use my power property. We get the log base 2 of x minus 2, whoops, forgot my 1/3. Now, again, we can't distribute. We're done. Okay? Very good. Now here we have natural log. The rule's the same, but just remember natural log is just base e. So I do have division, so that has to go first. We get the natural log of m squared minus the natural log of the square root of 3. I'm going to write this as a power. Okay, I want to write this as a power. I get the natural log of m squared, let me put that in parentheses, minus the natural log of 3 to the 1/2. And then I can just use my power rules. Two power rules. 2 natural log of m minus 1/3, 1/2, the natural log of 3. And there's our answer. And worst comes to worst, we just make them longer. Okay, so we have a division, so that has to go first. So we're going to get the natural log of x squared times x plus 3 minus the natural log of x minus 7. Again, please be careful, don't distribute. Now, if you notice over here, we have a product. So I can rewrite this one as the natural log of x squared plus the natural log of x plus 3. Put that in parentheses, helps out for later on, minus the natural log of x minus 7. And, of course, our last one, we have that power rule. Bring the 2 in front. So we get 2 natural log of x plus the natural log of x plus 3 minus the natural log of x minus 7. And there's our final answer here. For number 8, rewrite it. I'm going to rewrite this and expand quite a bit. This is the natural log of x squared times x plus 2 to the 1/2. Whoops, that's the square. Yeah, use my power rule to bring that down in front first. I get 1/2 the natural log of x squared times x plus 2. And now we're multiplying, so we're going to add them. Now be careful with the 1/2. This becomes 1/2 natural log of x squared plus 1/2 the natural log of x plus 2. This 1/2 has to go to both of them when we add it, because it's kind of like a distributive property here. And now the last thing we can do is just bring down your power. So this becomes just the natural log of x, because 1/2 of 2 is 1, plus 1/2 the natural log of x plus 2. And I like this problem because it really, natural log of x, because it really kind of shows how sometimes how expanding can make a problem simpler. And next year when we do derivatives, you will want to expand. All right, so we're done with part 1. When you go to part 2, we're going to take a look at condensing them.